Hi, good afternoon, everybody, and welcome to my talk on HTTP security headers. My name is Tim de Grande. I work for a company called Ordina in Belgium, and I've been a Java developer for a little over 15 years. I've always had an interest in security, and because of that, I started talking about it. People in my company started listening, and now I'm apparently the competence lead of application security, which basically means that I try to teach all my colleagues about how to write secure applications. And as we all know, security is important. It's not just in the abstract that, well, we don't want to be hacked. We have to write a secure application. We have to be safe, stuff like that. It goes further. If you look at modern-day browsers, if you don't serve your pages over HTTPS, you get this very big notification at the top, not secure. Your customers, if they see that, they will be less likely to start entering personal information, payment information, stuff like that. They don't want that. So at the very least, you need to be secure. You need to use HTTPS. It comes with a very nice padlock, and people will then be a little more sure about you. Now, how do we do this? Because, well, if you're like me, you don't just type HTTPS and all the stuff. You just type, I'm going to go to, in this case, ordina.be. Well, normally what you do is you put up a simple 301 redirect, move permanently, the browser will receive that call, and then it will redirect you to the correct secure page. So, very simple. Give me the HTTP page. Server says, no, use HTTPS. Browser then goes once again, OK, give me the page over HTTPS, and the server is more than happy to comply. But that still leaves a gap. There's still this first call over plain text where this evil person, the man in the middle, the mythical hacker who sees and does everything on your network, where he can start intercepting these things. So basically you say, give me the page. The man in the middle intercepts your requests and says to the server, OK, give me the page. The server says, no, HTTPS. I want to be secure. You should use HTTPS. So the man in the middle gets the HTTPS page. The server returns the page. And then what happens? The attacker basically returns your page over HTTP. The server thinks you're on a secure connection, but basically you're not. Now, how likely is this scenario? I've seen people say, OK, this is very complex. Nobody's ever going to use it. Let me ask a simple question. Who here is on the conference Wi-Fi? Almost everybody. Are you sure you're on the conference Wi-Fi, or are you on my Wi-Fi? Because if I set up an access point with exactly the same name and no security, I am that man in the middle. Every time you use an unsecured network, or anyone uses an unsecured network, you are in this situation. Someone could be in the middle between your traffic. So, because of that, some time ago, one of the HTTP security headers was added to the HTTP spec, and it's called HSTS, HTTP Strict Transport Protocol. Basically what it does, it tells the browser that my site has to be served over HTTPS for, in this case, about a year. When a browser receives this header over HTTPS, it will know that for the next year, you want your site to only be served over HTTPS. So if the user types HTTP blah, 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 your browser will not do that first insecure request. It will immediately make the secure connection. And obviously, this has some benefits. It makes it possible for you to secure your users a bit more. Basically, every time they visit your page, it gets renewed. Now, this is an age of about a year. Who here thinks that's long enough? Too much? Not enough? Well, it depends on your site, actually. The certificate is not really related, but it depends on your site. If you have a site like for instance, Facebook.com, where you expect users to come there every single day, 1 year is plenty. That's more than enough. If you have a website, for instance, where you have to enter your tax information, your users will most likely only drop by once a year. So, and if they want to file their taxes just over a year after they filed it last time, this header will have expired. So for that, you need a longer time. Basically, 1 year is a good minimum. Now, HSTS is not just that. You can also add a directive calling include subdomains. What does this thing do? Normally, when you say, I want to go to devoxx.org.ua, and you add the HSTS header, only connections to devoxx.org.ua will be protected by this directive. But if you're in a company like mine, you have dozens of subdomains, all running different tools. You don't want to protect all of those separately. So for that, the include subdomains directive was added. Basically, you add it on the main domain, and the browser will know for all subdomains I have, for this domain, I will now always use, for the next year, a secure connection. I will not try the insecure connection first, I will go straight to the HTTPS version. Which seems like a good idea, usually, but be very careful with this. As I said, you probably in your companies you have lots of subdomains for all kinds of things. If you enable include subdomains, you have to be sure that all those services on all those subdomains are accessible over HTTPS. If you've missed one, it's inaccessible. If you manage it completely, that's no problem because you can add a certificate, you can start serving it over HTTPS, but there are things like printers that expose a management API where you may not have the option to actually secure it via HTTPS. There could be ancient applications where it breaks if you start using HTTPS because it's just not configured to use it. So be careful. And then there is the final part, and that's called preload. Because up till now, we've still had that very first call. If you make your very first call to my site, it will still be insecure. That all-powerful man in the middle could still intercept that request. He could strip that header, he could do whatever he wants, and you would not get a secure connection to my site. And to mitigate that risk, the browser vendors, they started something that's called a preload list. The preload list allows you to actually ask the browser vendors to hard code into their browsers that your site always needs to be loaded over a secure connection. It's available on hstspreload.org, and you can very easily check your domain there. Now, of course, you can enter a domain there, and they will not automatically add it to the preload list. Would be a bit simple to do that, but dangerous too, because if your competition is not on HTTPS, you could simply lock them out completely. For some reason, they didn't really want that. But they decided, okay, this is too good a thing to have, so you want to be on this list, but you have to adhere to some criteria. For instance, first of all, of course, you have to have a valid certificate. If you don't have a valid certificate, you cannot be loaded over HTTPS, and HSTS is useless. You cannot use it. Your HTTP pages, they have to redirect to a secure version of the site. If you don't do the redirect, your preload will not be accepted. All your subdomains have to be served on HTTPS. They cannot validate this, of course, because they don't know what you have internally, but that does mean that you have to have the include subdomains directive inside the header you return. If you do that, they assume, well, you've probably tested everything and it's fine. So you have to include the subdomains. The max age has to be at least 1 year. So if you're not sure yet and you want to just do it for a short period of time for testing, you really don't want preloading, and they explicitly enforce this. Also, you have to include a preload directive. So even if you do HSTS, with include subdomains, with long message, with all the redirects, as long as you don't explicitly tell them, I want preload to be allowed, you will not be added to the list. Now, that's a very useful header, of course, but can you actually use it? Does any browser support it? Well, good thing for you, since quite a while, all major browsers have full support for this header. So, if there's one thing you take away from this, if you have a website, put it on HTTPS and enable this strict transport security. Also, make sure that your message is long enough, because if you have a website that's only visited once a year and you have an expiry time of a year, that's cutting it a bit too close, make it a bit longer. Be careful with include subdomains, because if you do that, you don't know what you might break inside your company. So test it thoroughly, make sure that everything is available on HTTPS. And most importantly, don't use preload prematurely. As I said, this is a hard-coded list that's supported by all browsers. But that also means that if you accidentally enable preloading and you're on that list, you're in a bit of troubles. Because you cannot easily be removed from it. It's a manual process. You need to ask the people who manage the list, please remove me. It takes a while. You need to wait until all your users have updated their browsers to the new version that doesn't include you on the list. So be careful with it. You can enable HSTS without the preload, without any problems, and start with a short message, make it longer until you're absolutely sure, and that way you won't get in trouble. Now, it's been mentioned before, HTTPS, it works based on a system of certificates. Does everybody know what a certificate is? More or less. Well, basically, when you connect to the server, it will send you a certificate. It will say, OK, here is my certificate. And the certificate contains quite a bit of information. It says it's a certificate for this domain. It was signed by this authority. And basically, there's a whole chain of certificate authorities all the way up to a root authority that is implicitly trusted by your operating system and your browser. And that certificate is then used to basically sign everything so that you know that the server you are connected to, the one that tells you this is my certificate, is also the server you want to connect to, and not the server of some man in the middle. Now, I've mentioned all certificates eventually lead back to a root certificate. Any idea how many root certificates are trusted by your browser?
70 or 30.
Sorry?
70 or 30.
70. I have bad news for you. Last time I checked on my laptop, there were 170. These are the major certificates providers, like VeriSign, GlobalSign, things like that, but also quite a few countries have their own root authority in there. Some countries who you might not really want to issue a certificate for your sites. Companies like Apple and Amazon, they also have their root certificates in there, so they could issue a certificate for your site if they wanted to. And, well, at times, other companies add certificates there. A couple of years ago, Lenovo, they came with a certificate that was installed on all their laptops with a very simple to crack password. That was the same certificate for everybody, trusted by the laptops. The certificate, the password was correct. It was way too simple, which resulted in people being able to create real certificates for sites they did not control. And they would be accepted by everybody who had a Lenovo laptop. So this system is not 100% secure. It was good enough at the beginning, but, well, things evolved. People got bad ideas. They started to use this for evil, and, well, it's a bit broken. To mitigate this, certificate pinning was implemented. What certificate pinning does is, well, the client says, okay, give me the page. The server returns the page, and it returns also a header that says, okay, I have a set of certificates that you are allowed to accept. Only the ones with these SHAs are valid for me. So the next time the client says, okay, only those. So the next time the client connects to the server returns a new certificate with a different SHA, probably because some man in the middle did something. The client says, oh no, wait a minute. I have a list here of certificates that are valid for you. The certificate you're now giving me, it's not on that list, so you get this error. Your connection is not private. Very big warning telling you something is wrong. So certificate pinning can seem like a very useful thing, and it was supported by Google Chrome. And then they decided, no, let's not do this anymore. The reason for this is, well, the pins, the certificates that you want to accept, and your content, they come through the same channel. So if, for some reason, you have to get a new certificate, your private key was compromised, someone did something they shouldn't have done, your operations team said, oh, we're going to switch to a new provider for our certificates, and forgot to tell you, all of a sudden, your site is no longer reachable. Certificate pinning also has a max age, which was normally set to about a year. Can you imagine your site being inaccessible for a whole year? How many customers do you think you would have left? So because of that, they decided, well, this is actually a bad idea for websites, and Google Chrome is now starting to roll back their support of this. So for websites, this is a bad idea. However, if you have a separate channel where you can produce new pins, then it's still very, very useful. Mobile applications, for instance, you can easily publish a new version of your app with the new pins in there, and all of a sudden, your application will once again work. But do not use this for your web applications. Instead, something new was thought up, which is not quite as strict, but which can still help you. And that's called certificate transparency. As I've said, there are quite a few certificate authorities, nearly 170 on my machine. Numbers vary, each computer has different ones. And the certificate authorities, they made an agreement that since about a year or so, they would publish every certificate they issue in a public log file. So every time you get a certificate for your site, or anyone gets a certificate for their site, that information is logged, and those logs are publicly accessible. And that's called certificate transparency. You can create these logs. This is from the Google overview. You can also have alerts on them. So basically, you can tell them, if a certificate is issued for my site, send me a warning. Normally, you should be aware what the expected lifetime of your certificates is, who your certificate authority is, and if you then see a strange thing, you can intercept immediately. Now, this system also introduces a new risk. Not sure if you can actually read what's on the slide. Since all certificates that are issued are now public, that also means that information that was previously hidden is now also visible. For instance, this is an overview of the first page of certificates issued for Amazon.com. It contains quite a few internal URLs used for testing. So where you previously had this very nice QA.whatever.com, which nobody knew, which was inaccessible, now all of a sudden it's visible to the world. People can try to access it. So if it's not locked up from the outside world, all of a sudden you have real-world users accessing your test environment, possibly seeing and doing stuff you really don't want them to do. certificate transparency also comes with its own header, and it's called expect-CT. Basically, this tells the browser that you only wanted to accept certificates that appear in these transparency lists. Now, I've just said that all certificate authorities have to publish them. So why would you still do this? Well, for instance, the story I just told you about Lenovo with Superfish, that was a certificate, that was basically a certificate, a root certificate, that anybody could use to generate a certificate for your site. Of course, if someone like that generates their certificates, they're not going to publish it. If they don't, well, the browser will say, ah, no, sorry. This certificate, I don't see it in the logs, so it's probably not a valid one. And once again, the connection will not be made, and your user will be secure. Of course, if some third party will still manage to get an actual certificate authority to publish a certificate for you, the certificate will be valid, but that's where the logging comes in. That's where you can immediately say, hey, this is not right. You can contact the certificate authority and have them revoke the certificate, and that way the window of opportunity becomes a lot smaller. Well, expect-CT is still relatively new. It's not supported by all browsers yet. Basically, it's Chrome and Opera. But the benefit of these things is, if you add this header to the response, the other browsers will just ignore it. If they see a header they don't know, they don't do anything special. They will just serve the page as normal. So, still, there's very limited support. And you can enable a report-only mode for this header. What that means is, if the browser encounters a certificate that's not on the certificate transparency log files, it will still allow the page to be displayed, but you will get a warning. It will send a specific message to a system that you choose, and it will just say, okay, I got a hit. Someone requested this page on this URL, and they got a certificate that was incorrect. If you then monitor those logs, you can see what's happening, and you can find out if, for instance, there is a company that has their own SSL interceptor, and, well, for instance, if possible, you can mitigate it. Enforcing the header, only do this when it's stable. Just add the enforce directive at the end, and then the browsers will know, okay, now I have to block users that don't, now I have to block certificates that don't appear in these logs. That's the most secure option. The other one is just for testing. You use that until you're sure that you've achieved what you want to achieve, that you don't get any strange hits that suddenly block access to your site. So only then do you activate the enforce directive. Now, at the moment, we've used the header to say, okay, always use HTTPS, and only accept those certificates that are in the transparency logs. Does that mean our site is secure? Does that mean that nobody can do funny stuff with it? No, I see people shaking their head. Does anybody know about cross-site scripting? Quite a few people have heard of it. Basically, what it means is that you can trick a website into executing scripts that you control. So you can say, this is a fake example, by the way, if you can inject JavaScript or some other kind of script into a website, you can make that website do everything that the user of that website is allowed to do at the moment. The favorite example of everybody is always the banking websites. If I can inject JavaScript into your bank's website, I can start transferring money to my account. You don't have to do anything. It's quite obvious that people don't want this. So there is some cross-site scripting protection in the browser, but there's also this thing, a content security policy. A content security policy is basically yet another header that limits what the browser is allowed to do with your site. And it's a very expansive set of instructions that you can give it. I've listed the possible sources that you can filter on. And as you can see, you can filter on images, you can filter on styles, fonts, scripts, media, all kinds of things. Basically, what you can do there is you can tell the browser, okay, only accept images that are served from this specific domain, or only accept images that are served from this domain and the specific CDNs that you use. You can limit the types and the amounts of style sheets that can be loaded. In case you didn't know, style sheets can also be used to do strange things on your website. You can limit where fonts come from. You can limit scripts, media, whatever. Besides that, there are some other things. You can prevent your page from being displayed inside a frame. Does anybody know why that's a good idea? Some people do. Well, basically what you can do, if you're an attacker, is you make a new page, you load your victim's website inside a frame, and you put a nice big image over it with some places where you want users to click, make it a game, whatever. Users click it, and what they don't realize is that while they think they're clicking the game, they're actually clicking on stuff inside your website. And then they can do things that they're not aware they're doing. You can also have stuff like require SRI. SRI is sub-resource integrity. Basically, it means that if you load a script, you include a hash for the script, so that you know that the script has not been tampered with. Why would you do that? Well, I think most of us nowadays load scripts from content delivery networks. You say, okay, I want this version of Angular, of jQuery, of whatever, and instead of downloading it, hosting it myself, I'm going to let my users download it from Google or whatever. But you can never be sure that someone has not gained access to that script and modified it in some way. What SRI does is, basically, it downloads the script, it calculates a hash, and if that hash matches the value that you've put in your script tag, it will execute. If it doesn't, it will block the script. So you can protect your users like that against someone changing a library somewhere. Of course, that does mean that you are not supposed to depend on the latest version, because every time the version is upgraded, the latest version also changes, and obviously the hash changes, and your site would break. Now, of course, using the latest version is never a good idea when it comes to security, because you never know what you're pulling in, but that's a different story. You can also limit stuff by adding a nonce to the scripts, basically number used once, but that's a story for another time. Now, content security policy is quite well supported by most browsers. As you can see, base support is available on all major browsers. Support for some extra functionalities, more extended, more specific, is more limited, but still quite widespread. Now, the final directive that it has is a report URI. Once again, the same as with the expect CT. You add the report URI, and when something happens on your page that is blocked by the content security policy, it will send a report to that URI. Obviously, you want to monitor those reports, because if a report goes in, that means that something on your site is either broken or someone has tried an attack. Or user did something stupid, but the first two should concern you. So always monitor those reports. Now, usually you don't want to implement stuff that can break your site like this without really testing it. And as I'm sure you know, when you try something out in your testing environment, your staging environment, everything works. It works exactly as you want it to. Then you push it to production, and it burns. Stuff breaks, your people can't use the application anymore, everybody panics, you have to roll back. So for that, this header also comes with a report-only variant. It's basically the same header, except the name ends with report-only. What happens is, your browser will still look at all the policies, but it will allow everything. It will only send you the report. So that means that you can actually test in production without breaking stuff. You get all the reports from all your users doing everything they always do, even the strange things, and you get a report. And you can use that to basically look and see where you still need to tweak your header, where you still need to say, I forgot that people also need to submit a form there, or that we loaded that specific script in certain cases. You can still add them to the policy without breaking anything. So, what are the takeaways here? CSP, it's actually good to have. You want it. You want to be able to limit what the browser can do with your application. But it's very extensive. You can do quite a lot with it, and it's hard to master. Fortunately for us, the people developing this, they knew about that, so they added the report-only mode. So once you make changes to your CSP, don't do it in the content security policy directly. Always do it in the report-only version for a while. At that point, at some point in the future, you know that, okay, my changes are right, only then you migrate them to the actual security policy. And keep monitoring those reports. Because, well, nowadays, we don't just load scripts for ourselves. You often load scripts from third parties, tracking links, stuff like that. So if all of a sudden something breaks, you want to know that. So you have to keep an eye on those logs. Also, if someone is trying a cross-site scripting vulnerability on your site, those logs will also mention that to you. They will say, hey, on this page, this specific script was trying to execute, and apparently that's not allowed. So that means that you can very quickly see when these kinds of things are happening and stop them. So, a short overview. HTTPS is good. You have to use it. All the stories you've heard before, well, it's slow, it's expensive, that's no longer correct. Nowadays, HTTPS can be free. If you haven't heard of it, Let's Encrypt.org, they issue free certificates. All you need to do is run their scripts, and they change the configuration, they do everything. It's very hands-off. It's also faster. I see confused looks. A little while ago, HTTP version 2 was released, which brings an enormous speed boost over HTTP version 1, but it's only available on secure connections. You cannot use HTTP version 2 over HTTP, only HTTPS. So the combination HTTP 2 and HTTPS is a lot faster than HTTP version 1 over HTTP. You want to use strict transport security to tell the browser you want a secure connection. Because otherwise you always get this it's a short redirect cycle that might enable an attacker, a man in the middle, to hijack the traffic and do stuff that you don't want, that you really don't want to use. Once again, be careful about preloading. Only do that when you're absolutely sure. If you do it too soon, you could be in a world of trouble trying to get it reversed. It could take a few weeks or even a few months. Certificate pinning, very useful for mobile applications or other instances where you have a separate channel to deliver your pins. Don't use it for your website. If someone accidentally changes your certificate authority, or on purpose, and forgets to tell you, your site breaks. It happened to Smashing Magazine. They were very lucky that they managed to recover from it by using a certificate request that was still valid to get a new certificate, because otherwise they would have been inaccessible for a year. And good luck communicating to your customers that for the next year you might want to use a different domain name if your website is not available. Expect CT. Enable this to reduce man-in-the-middle possibilities. It doesn't eliminate them completely, but that's why you have the logging of the certificate transparency logs. Monitor those. The content security policy, it really tells your browser what the page is allowed to do. It's very fine-grained. And like anything that is not specifically allowed is forbidden. So you can really tell it how to behave, what you want it to do, what you don't want it to do. Since everything that's not allowed is forbidden, just make sure that you actually test it. Use the report-only mode to make sure that the stuff that you put on there does not break your whole site. So, we have some time left for questions.
Hello? It's not working. Okay.
I think we turned on.
I got a SDK,
Mm-hmm.
and my colleagues think that we should better use traffic encryption versus SSL pinning. They think it's more secure.
Sorry, they would use what?
Traffic encrypt traffic over SSL pinning.
So encrypts.
Encrypt traffic use key encryption is
Yes.
of like payload.
So they want instead of using SSL, they want to use a specific encryption scheme.
Instead of using certificate pinning in mobile app.
A mobile app. I think you can use both, actually. If you use certificate pinning, it's in Android apps, it's relatively simple. You just add the pins that you want to allow in the manifest, and Android itself will enforce it. If you want to use encryption, you get the whole key management stuff again. You have to make sure that the key is available on the client device. You can use both, but be careful. If you have a key on a client device, you have to make sure you protect the key. And protecting keys on a device that you don't have under control, it's always difficult. There are ways, but it's something else that you have to keep in mind. Something that SSL actually manages for you.
Yes, but on the other side, companies like Komodo could be hacked and hackers could issue certificates.
Exactly. So that's the certificate transparency part. If Komodo gets hacked and a certificate is issued for your site, you should monitor those logs. You have several sites. Even Facebook has one, for instance. As soon as Komodo is hacked and someone issues a certificate for your site, you get a notification. Hey, Komodo issued this certificate. And then you or your security team, they call Komodo and say, hey, why did you issue a certificate for our site? We did not ask this. So, okay, you're vulnerable for a period of time, which hopefully, if your security team is awake, should be very short. But yeah, I see that the encryption there could mitigate it a bit, but
I guess we should use both.
Probably.
Thank you.
Okay.
The first example you showed us with man-in-the-middle attack, well, you said that an attacker can intercept our HTTP call, receive an HTTPS version of the page, and receive the page to us. But the page we receive, it will be over the HTTP protocol, so the browser will still show us this not secure warning, right?
Exactly. Yeah.
Yes. So it's not that dangerous because the user still sees what page he's receiving.
Yeah, the user still sees that the page is not secure, but you also have no control over exactly what that attacker is doing with your page. So they could put all kinds of wrong information there. They could start inserting all kinds of ads that you really don't want associated with your sites. They could deliver malicious payloads to actually get into your user's computer. And at that point, the user, all he knows is, I surfed to your site, I got a virus. He doesn't know there was someone in the middle. He says, your site is not secure, you gave me a virus. I don't think you really want that to happen. So that's why these things, they may seem harmless, but they can be quite dangerous.
And another question. When you said about the content security policy, you mentioned it in the context of XSS attacks. Yeah. But how does it happen? When XSS attack appears, the source of the malicious JavaScript is your page. It's served from the source, from your server. How can you protect?
By default, a content security policy will not allow inline scripts. And which basically means that if you have a script with JavaScript inside the page, the content security policy will stop it. It will only allow scripts that are loaded from with script source equals something. Most, if not all, cross-site scripting attacks will use inline scripting. Okay, you say now they can simply add the source, but if they want to add the source, they also have to add the host where the script is published to your header, and it really makes it a lot harder. I'm not saying it becomes impossible, because if you use a framework like Angular or jQuery or whatever, most likely there are some bugs in there that could be used to still mount a cross-site scripting attack, but it becomes harder. And when it comes to securing your application, it's nearly impossible to build something that is 100% secure and still usable for your users. It's like this old joke. There are two guys walking in the woods, and all of a sudden they see a bear. And one of the guys, he kneels down and starts tightening his laces. And the other guy says, what are you doing? You can't outrun the bear. No, he says, I just need to outrun you. It's the same thing. You don't have to be the most secure page on the internet. You just have to be a bit more secure, a bit harder to hack than the other guys. Because most attackers, they are not these sophisticated hackers that you see on TV. They are 15, 16-year-old kids sitting in their bedroom, running some scripts they found on the internet, just trying stuff. And, well, if you can keep those out, you've blocked most of the attacks already. If there's really a nation state that's coming after you, I don't think this is going to help you. They have other ways of getting in. So yeah, it's a trade-off. You have to be as secure as possible, but you can never be 100% secure.
Great, thank you.
Okay, any other questions?
Thanks a lot for a great presentation. So I'm just wondering, for example, your domain is hijacked, right? Mm-hmm. So, or you have any other issue like that, right? So, and you have a website, and the website is crawled by Google. So do search engines take into considerations like security aspects of the websites that they actually crawl? For example, like imagine that a domain is hijacked, and then the website becomes higher it's been ranked higher, but it's a malicious website already. So can you talk about that?
It's a difficult question because search engines don't like to publish exactly how they rank stuff. The only thing that's well known is that Google actually gives some bonus points if you serve your page over a secure connection. So the exact same page, if you would post it only on HTTP or on HTTPS, the secure version would rank higher in Google. If your domain serves malicious software, they will also drop you in the rankings. For other things, I really don't know. I'm sorry. Okay, any other questions? In that case, thank you very much.